Hello everyone, let us continue learning C language. In this video, we are going to talk about one main important component in C language that is none other than the main function. Now we all know that main is a user-defined function, and main is the default function that starts getting executed by itself once when the program execution starts. And the main function has different alternative ways of being defined. Let us see what are those. Now in common, most of you would have noticed the main function is being written with various different return types that could either be int main function or void main function. That is, it could be either an int main function, or it could even be a void main function, or sometimes it could be int main function with some more parameters, int argc, which represents argument count, and followed by a two-dimensional character array, which represents the argument values. And we all know what do you mean by argument count and argument values, which are none other than the count of command line arguments that come along with the main function, and also the argument values that come along with the main function execution call. And we can also have the same thing as void main with the same argument count and argument value as its parameters. Yeah. So these are the common ways of main function being defined. And before we proceed with the definition of the main function, let us talk about what is main and why it is required. Okay. Now main function, as I told you earlier, it is the base function that starts executed by the compiler the moment the program execution starts. Any other function that is being used or defined or predefined inside any other header file, if that has to be executed, it has to be called within the main function. Unless and until it won't be executed. And also talking about the varieties of return types we have for the main function. As you could notice, the first line and the third line says the main function returns the value of integer. And the last two, second and fourth line talks about the return type of the main function being void. And third and fourth way of execution is nothing but they have parameters in place. Yes. Now these are the various ways of using the main function. Now getting exactly to the point, why do we have two different ways of return types? That is, one is int, another one is void. And also we have a very big question in front of us, that is, even though it is an int main function, it returns an integer value. We are not returning any integer value. We are specifically returning only return 0 statement. That is, the last line of our main function will always be return 0 if the return type is integers. And also, if you could notice, the two different ways of using int as a return type of the main function and void as a return type of the main function. In GCC compiler, in the modern day GCC compiler, we can very well notice the main function should have int as a return type. It won't accept void return types. Whereas the older Turbo C versions, okay, the older Turbo C versions or the Borland C versions, we could have noticed it allows both kind of having int main or void main. Now, what is the difference here? Now, why should I have int main? And why can't void main in place? And also, even though it is int main, why can't I return any other integers? It could be +1, -1, or any other positive or negative integers. Doesn't matter. We are returning only 0. Why is that question? Okay. Now to answer it, whenever we compile the whole code, yes, whenever we compile this, any C language for that matter, it could be a simplistic hello world program. The moment you compile it, what happens? The next is nothing but the file will get converted into a .o file, which is called as the object file. For example, let's say you name your file as program.c. Okay, this is the name we have given to the program which we have written. It is called program.c. When we compile it, the first stage, what happens is nothing but it creates program.o. That is, it creates an object file, and next that object file is next converted into program.exe, and this exe is a very important part. It says the executable file in terms of Windows environment, and this file has this part of exe file has different ways, because when it goes to Linux environment, it will be made as program.out, because program.out is the extension that is given in the Linux environment to have an executable file. So the executable file extensions varies from operating system to operating system. That is, based upon Windows, it is .exe. For Mac, it is different. For Linux, it is different. Let us hold at that point right now. So the executable file extension varies between different operating systems. Let us talk about the middle file, which is called as the program.o file. And also, let us all have in mind, we have this compiler called GCC, and this GCC has different types of switches. Okay, switches in the sense, GCC, it says fatal error, no input file, which is because I'm not passing any input file to compile here. Now let us also talk about what are the switches does GCC have. Okay, for which I'm going to say GCC help, which is also a switch, which will tell you all the possible switches available in GCC compiler. Okay, now this GCC compiler, we have got varieties of switches. To begin with, we have the switch called --help, which displays the information. The whole information what you see on the screen, to display this, we need this --help. Okay, and we also have --target-help. Now this displays a specific information, not all the information, it depends only the specific information. Okay. Now the crucial part what we need to do here, look at this point is nothing but the -s part and the -c part and -o part. Now these are the common things which we use. Now we all know that -o switch. This is where we are providing the file name in which we want our executable file to be present. If we are not providing any file name, default value for the -o is nothing but a.exe. So a is the file name. So on the extension in Windows is .exe. So it will take the file name of a. Now what about the -c and -s? Okay. Now this part, okay, look at this -c. It says compile and assemble, do not link. And this -s says compile only, do not assemble or link. Okay. Now let us see what happens. Let us open this folder. I am having the whole working directory, the whole working part inside my directory called d:/c basics. So this is where I'm storing all the files what we have done in our sessions. Okay. I'll open my Explorer. And in my D directory, I have a folder called C basics. I'll open up that folder as well. Now you could see a lot of different files here, which is either a C file or it is a C header source file, or it is an application file, whatever we have created as exe file. All the things are here. So I would like to group all the files here based upon their types. So I can see what are the types I have. I have 13 applications, 2 header files, and 13 C source files. I've got these 3 file types here. Now what I'll do is, in this place, in my editor window, I'm going to create a file, and this is simply going to be a basic file, say a hello world file. So I'll say hello.c. I'll compile it, #include stdio.h, and an int main function. I'll printf hello world here, end with the semicolon, and I'll return 0 in place. Okay. Now this time again I'm going to compile it. I'm saying GCC. I'm going to compile the file hello.c with the switch of -s. Now you could see it has successfully compiled. Okay, it has successfully compiled. Now no application is created. It has created an application called a.exe. It has done a regular compilation. a.exe is created. So I'll run this file A. It prints hello world. This is the output of the exact file here. Okay. Now instead I'll use a different switch here. I'll remove that file. rm-r a.exe. I've removed that file. I'll compile it one more time with the switch of -c. Now you could see there is a O file that is created, file type of O. It says hello.o. What has happened here is nothing but the compilation is done successfully. We already saw all possible switches. So I'll do it again. --target-help -c GCC -help. So in this part, we have this switch called -c, which will compile and assemble, but do not link. So this is the part. It will not link. It will not link to any file. So it only creates the object file, and that object file is not linked to the executable file. So how do we link it again? So we have this file GCC. We have this file hello.o, and this is all about how we compile and how the compiled object file is getting linked to your executable file, .exe file, and so on, right? Now, these are the stages in terms of compilation. You have your C language file, .c file, and when you compile it, that becomes an object file, and that object file will get transferred into an exe file. Okay, these are the stages. And if you don't want the final linking to happen, the final .exe file output to come out, rather you want to stop at some point of the object file alone. Okay, that is when we can have the switch called -c, and the switch of -s also similar does a similar action. And there are a lot of other similar options which we can perform with the help of the GCC command. Okay. Now, in the place of it, before we get in depth about all the object files and all the binary files. Okay. We wanted to know the point of int main return 0 statement. Now, hope you would have understood the part of the object file, the purpose of return 0 statement. Okay. Now, any command we call, any file execution, whatever we do, the execution of .exe file or .msi file, which extends for Microsoft installer files, all these files are executed from the command prompt window, or that runs on the native processor what we are running on the machines. Okay. Whenever we provide some memory to your program, right, whatever we write here, these are called as programs, and these programs in their run state, that is, we have this file called hello, any exe file from this folder. Okay, any exe file for that matter. So it executed, right? Now this is a file. This is basically a program, and when I'm running it, when I'm saying arrays.exe, at that moment this particular file becomes a process. And that process can be overlooked from your task manager. Okay, when you run this file, I'm opening up my task manager to show you what is happening around. So I'll clear this. I'll run some exe, some random exe, what we have created already in our sessions. I'm running this function.exe. It runs quickly. I'll run an exe file which stands for our input. So this is a file. You could see I'm running this loops.exe. This is a random file, but this file is waiting for a user input. Okay. So this process, it was earlier a program. Now this has become a process, and this process is still in its run state. Okay. Now in my Visual Studio Code is what we are running here. We are running out a console command window here. We are not able to spot the different loops here. So what I'll do is I'll break this process. I'll pull it out in my command prompt window. I'm starting a new command prompt window with the same thing. So this is a command prompt what I have here. And here I'll run the file called loops.exe. Now in my task manager, you can see the command prompt what we're running here, Windows command prompt. In the command prompt, there is a file you see here which is called as loops. Now this is basically a process. Okay. When I kill this process, okay, this process is still running. I'll keep this window in parallel spaces. So I'll right click on this and I'll call this as end task. You could see this loops, it was executing and it was stopped by me from the command, from the task manager window. Okay. So any process you run here has its inferences in the task manager. It can be controlled, it can be executed, it can be stopped or overlooked from here. It can be paused for a while, it can be stopped here. So what is happening in the background is nothing but any process we are running. Any program in its run state is called as a process, and that process, when it is on the running phase, it will be allocated with the designated memory in the processor. The Intel i3 processor, or i5 or i7 or i9 processor, whatever you run on your machine. And from that processor, that process would have been allocated a specific memory. And whenever you use a memory, it is kind of you're using a locker in a bank, or you're using a room from a resort. Okay. When you go check in, you provide all the details of your side, you validate yourself, and then you check in into the hotel or the restaurant or the bank locker. You validate yourself. Once when your usage is done, when you're done using it, you're supposed to properly vacate from the space. The meaning of properly vacating is nothing but you will clear all your belongings from that hotel room or the bank locker, and you will hand over the key to the specific in charge person. Either it could be a bank manager or the hotel in charge. You're supposed to return back the key of the room which you were using. Yes, that is what's called as a proper usage. You rent from them, you take up their space, you use it for your purpose, and once you're done with your process, you go return it. Okay, this is a clean sheet, we call it, right? Now, the same thing should have been followed by these processes also. So what a process should do, when a program becomes a process, that process would have been allocated with a specific memory. from the processor. So the process is going to use the memory from the processor. After using the memory, after it is done executing it, after it is it's done its whole work, it has to come out of the processor in a proper handshake way. It has to properly return back the memory to the processor and then leave. That sequence of work is checked by this statement called return zero statement. When you return zero, it is nothing but you're flashing the whole memory from the processor, and then you're placing zero in the memory. After clearing the whole room, you are placing an empty zero value inside the processor memory, saying that I am completely done with the whole process. That is the meaning of return zero statement. Now, what happens? You have a bug in your code. There is a malfunction in the program what you have written, because of which the program is not running the whole n number of lines what you have written on the page. Let's say you assume you have written 10 number of lines in your program, and your program terminates in between because of some random x, y, z reasons. Okay, in that stage of an abnormal termination of your whole process, the processor at which we are running the processor should be alerted, should be given an alert message saying this process which ran on this particular memory has ended up with an error. Okay, it should be ended up with an error message, error code we call it, and technically this is called as error code. An error code should be passed to the processor. Okay, and that is done with the help of integer values. If return zero is not in place, if return zero is not executed, the last line of the process, if that line is not executed, obviously there would have been some dump garbage that will be stored in the memory, which is used by this process. So once when the processor goes back and checks that particular memory block, if it finds some random data other than zero, then the processor decides that this process ran into a crash situation. It is not responding anymore. It has no value, whatever it is. Okay, and that is how the processor or the operating system gets to know about the status of the process what we're running. And this is applicable to all the other processes whatever you have on the machine. Every single application you have on the machine, it could be either your Microsoft Windows, Word, MS Office Word, or MS Office PowerPoint, or MS Office Excel, or any other gaming application. It could be any of the games you play, FIFA, cricket, or PES, whatever the game it could be, or it could be any other application. It could be even your Python compiler or anything for that matter. Everything is basically an process in your compiler, in your processor. Yes. In that case, if any of such program runs into an exception situation, error situation, you could see that is very well handled by the operating system. That is more commonly in Windows environment. You can always see this old pop-up message. People who are using old Windows 7 environments or Windows XP systems, you could always often come across this window called your program ran into some process. You want to send some report to the Microsoft. Don't send with these two buttons. Send report and don't end some such termed buttons at the bottom. You can see such windows very often, right? And that window pops up because some of the process, maybe one or two processes is running inside your processor at the back end has ran into a problem. That is the reason why you see that pop-up window. Okay. Now, this is not only with the operating system what we have on our PCs. This is even common applicable to the OS like iOS, which runs on your phone, or your Android OS. Okay. In Android OS also, you can often say older Android phones to be specific, right? Which is maybe 3 years or 4 years older Android phones. You can often see this window which says this process, some random process name stating that that is not responding anymore. Do you want to send data, wait, or close? You'll have these three options: send data, send report, wait for the process to respond, or end the process. Okay. And that pop-up message is brought on the top by the Android operating system, which is running on the background. Okay. And now, since now you know that why the int main is very important, because only because of the int main functionality in the last return zero statement, the OS was able to communicate to the process what you are running. Your process and the processor, they are communicating with the help of the return zero statement. Now, what if I write a program with void main statement? Because as I told you, for Windows, it is mandatory. For the modern day GCC compiler, int main is mandatory. Then what are the operating systems that we're using void main function, and what a void main could do to your process? That is the question we again come up with. In that scenario, I would say there are few operating systems like Linux or Mac OS to be more specific about. Now, those operating systems are least bothered about your process, because what most of such kind of operating systems would do is nothing but they would literally isolate the process what you're going to run. They are going to isolate your process into a unique memory, so that even if the process what we are running gets crashed, that will not affect the flow of the other programs. They'll make sure that that particular crash scenario will not affect the flow of the other programs. So in such situations, the operating system is least bothered about your status. It is like you are affected with COVID virus, but you are put into a separate cell so that you cannot communicate with any other person, so that you cannot spread the virus to anybody. So we are least bothered about you. Either you survive or you die, it doesn't matter. So it is such kind of a statement what the operating system is going to make. Okay. So in such scenarios, it is very evident that we can always go ahead with void main functionalities, but that is purely operating system dependent. Yes. Hope this briefing of about main function was pretty much clear for you. See you in the next part of the video. Thank you.